But if you talk about everything, sound, oh, how many bits is your MP3? Oh, it's 312 bits.
It's a number of them.
Right? And what you have there is you've got two things. You've got how many states. So you've got an audio wave, and it comes in its voltages, and it's this, and that represents your signal.
Yeah.
Right? Well, what you do is you divide that up into lots and lots of measurements. Right? And so on a CD, it's 44,000 times per second, but that's a low bit rate now. People go,
per second.
Only, right? But 44,000 times a second, you take a measurement, and each one of those
so many times, that's not
is
many
24
anymore.
bits.
Okay.
So you've got 24 bits. So at 44,000 times a second, it makes a measurement and it represents it using 24 bits, which gives you 0 to, I can't remember the number, but it's so many, we're getting up towards billions by that stage. That you can, so it means you can describe this shape fairly precisely, but if you go to 48-bit, then you've got more states. And if you go up to, if you go to 100,000
so it's kind of like
times a second, then that's how often it measured it. And so then it gets stored this many times a second, that many bits for each one.
So it's like frames per second. It's like
It is exactly like frames
more
per second.
information
Yeah.
coming through. So it's more detailed, it's more accurate.
Yeah, and it's the same with pictures. If you look at
pixels per inch.
Yes, and if you have a screen here, right, and that is drawn up into a grid, right, of whatever, and you've got your screen, 1024 by 768 or whatever your screen resolution is.
720 by 1080.
There you go. So then you get 700. I think it'd be 720 this way and 1080 that way.
Mm-hmm.
Right, and each bit you have.
I should have gone higher resolution. I should have said 1920 by 1280.
Right, but you then have for every frame. Now this is a simplification. They've got sophisticated algorithms to compress it, but we won't go into that. But if we talk about raw stuff that's coming off that sensor in your camera,
yeah,
it is looking at that. There's an array of things, light hit it, and this one here, each one of those has, if you've got 64-bit colour, 64 bits. So for every one of those, that is analysed.
Gotcha.
Cameras are actually trickier because the pixels are only sensitive to light, and they don't. And there's a total amount of light on it.
Yeah.
So in actual fact, there's a thing called Bartonov mask. Yeah. I'm thinking. I'm thinking about my astrophotography. There's another type of mask that I won't go into. Anyway, and it says that this pixel here is telling us the red, and what they do is they put a filter over that only lets red light in.
Right.
And then it says this one is green, and it's got a filter over it that only lets green. And usually you have blue, and you get a chunk of 4. And that mask is applied over here, and only green light hits this, only red. So you end up with this being one element of colour.
Okay.
Whereas if, we won't go into that, monochrome cameras, you don't have any, you take an image with red and another one with green and another one with blue and another one with luminance and whatever, for astrophotography.
Right.
And you build up an image composite of all three, and that way you get high definition. But in a normal colour camera that comes off colour, there is actually a mask over the sensor, and it has, this one only is red, this one's green, and these two are blue or whatever. So you need to know if you're going from raw to colour, you have to convert it. Your camera does it for you normally, but if you take a raw image and you have to do it, you have to apply the right mask to turn it from monochrome to colour.
Right.
But basically each one of these is 64. And then for a movie, you have so many of those a second.
Right.
And it just, it just keeps getting a new, another.
Right.
And that just stored up as a whole pile of chunks. And so when you look at a binary file, which is, you look at the file and you can see there's noughts and ones.
Yeah.
But if you're doing it reverse engineering, there's a program called AXE that lets you look at the binary. You have to say what each chunk means. You have to tell it.
Right.
This bit means this bit means this bit, and it breaks up the bunches of just noughts and ones that are stored in your memory or on your hard drive or wherever it's stored. It just has to tell it, break it up. So this bit's the colour, this bit's the frame. If you've got a movie, the movie's got sound and it's got audio.
Yeah.
And you have the decoder that's coming in. It's just getting bunches and bunches of noughts and ones. And you have to say, well, these bits here, literally these bits, represent the colour of this, and that is the colour of this bit here. And so there's a chunk that is the picture, and there's a chunk that's the audio, and you have to synchronise the two so that they're, that the audio is being read at the right frequency and the frame rate's being read in the right frequency for the movie. But it all comes down to binary.
That's wild.
Everything gets stored
Wild.
as your noughts and ones.
Okay.
Does that actually make sense?
I think it does make sense. Bizarrely, I think it does make sense.
Now, this points to something we're going to bump into real soon.
Right.
And that is data types. Okay. So as soon as we get onto a computer, and as soon as we start trying to write some code, you're going to get things where you create a new type. And that type is a character. So let's just say this is a class, right? And its character, and we tell it that then inside of here we have various components, and you might have there might be an image stored over here, right? And that is a picture of the character.
Yeah.
Right? But inside of here, in the properties, you've got its image, right? And you say, point that to here, there, and that image is of type JPEG, JPG, or it could be a TIFF, or it could be a GIF, or it could
PNG
be
is
PNG, right? So you have to tell the computer program that this bit of memory over here, which is all sorts of noughts and ones, right? And there's, for this, if you've got a 2 megapixel image, it's 2 million, a 2 megabyte image, it's 2 million bytes.
Right.
So you've got your 8, right? Whatever, 8. there's your byte, right? It's that times 2 million, right? I just wrote on the wall. And so that is your file, and then the thing that you tell Python in your class that this image is a JPEG, a JPG, right? And then it has built into it the stuff that knows, okay, JPEG format is, it's got a header, and that header is so many bytes, right? And then there's at the beginning of the image, so this is reading off. It knows how to read. It knows how to interpret a bunch of noughts and ones as a JPEG.
Right.
And in that header, it'll have something like, it'll say how long the file is, and there'll be, so there's a structure. And if you look up JPEG, there's a definition of the standard of JPEG. And if you any program that has the ability to display JPEGs knows how to interpret a JPEG file.
Right.
It'll up in the header. It'll tell it what the resolution is. It'll tell it what compression factor it's got. It'll tell it all these things. But ultimately, it turns into just a lot of noughts and ones.
Okay.
Because megabytes is 8 bits, so it's that whatever megabytes
Right.
times 8 is how many switches it takes.
Right.
And if you had to do that on a punch tape, imagine how big it'd be. And that's what they used to have, which is why you used to have these really clunky images.
They used to, and if we're talking about early video games, you had 8-bit
Yes.
games.
Yeah.
You
And
know?
you see
that
how
was very
big the
exciting when you
screens
got
are.
to 16-bit games.
Yes,
Yeah.
and because they had much more colour and they had a higher frame resolution.
Yeah.
Right?
This is interesting to me in regards to the very early Pokemon games.
Mhm.
This is getting off, but so you've got your Game Boy, your first generation Game Boys, and the cartridges held all of the memory for the save file and for running the game, and you stick in like Pokemon, and they in particular were apparently so clever with how they use space, and apparently the programming for it was wild, and it's kind of a mess to look at, but it's because they were making use of every single piece of space that they could and kind of Tetrising everything in around
And they're
each
probably
other.
also using low-level code like assembler or something to make it really fast to read the instructions. So you got high...
And so then on top of that, you've just got these, like, the pixel art is very just like, you know, it's grayscale, so it's like either black, blank.
So, all of this, so when you look at your object, which you create, or all your variables in your object, whenever you code, so when you're working with a computer, you say, I want to store something, but this is going to be a set of characters, so it's going to be a string. So there's type string. And then string, the string class, has things like you can search and replace in it. You can just have a string and then go dot, and then get it to sort, or remove, or replace, or whatever. So there's a string. This is a string, and you say dot replace, and you replace E with O, and it'll replace every time there's an E in that. This is a string, which I don't think there is any. It will replace them with an O. But so there's all these operations you can use on these. So everything is classes and types. So what we're doing is we say we're creating a type of a character, and this character has an image, and that type is a JPEG, and the JPEG type is defined by a standard, and all JPEG images, if they render properly, are abiding to that. You've got another one. This is a number. This is a number. Well, I don't need. What's my score going to be out of 10? So you could go for a long integer because you don't need points, decimal points. So you go, I want 0 to 10. Well, you could ask for a long integer, and it's going to give you 64 bits to represent that, which gives you something 16.4 billion or something, I don't know. But it's a huge number. And you go, well, I only need to store 0 to 10. So you can just ask for a short integer or an integer. Because we've got so much memory now that it doesn't matter.
Yeah.
You just go, give me an integer. But if you want to store something that's got decimal points, then you want to have you got singles and doubles and whatever. So you can have, but what it's saying is, give me this many bits, and it's for this type of data. So you have inside your program, everything has a type, and the type tells the program what this bit of information represents and how to interpret it.
Right.
And so when you write a class, you're creating a new way of representing it, but that class has got age. And it's going to be, unless you want to have 64 and a half, it's going to have an integer, but you want to save 0 to 100 in case people live to 100. So, but if you just get an integer, it's plus minus 32,000 or something, because that's what you get. But if you were writing something to run on a really micro computer that you wanted to have embedded in a little device, then you say, well, I don't even need that. And if I just want something, you want true or false, there's a Boolean type, and that explicitly gets interpreted as true or false.
Okay.
And so if you've got a Boolean, you can represent it as just one switch 0 and 1. But you can have it where if you've got a whole lot of things that just want to be true or false, you can have a bitmap. And that bitmap just says on, off, on, off, off. And when they were sending things up to the moon, they didn't have enough memory to do much. So everything they could that was an on-off switch, they just had as a single on-off bit. and they were really hunting for every. I can't remember the number, but something like, I can't remember how many million times more code in your average car now that you buy new than what sent people into space.
Which is wild.
And that's because if you want to have Bluetooth, you've got to have all the code to interpret Bluetooth. If you want to have climate control, you've got all of that. But memory is cheap. Uncle Dave had a Encyclopedia Britannica years ago. I saw it, and it was from 1967, and they said memory has got as cheap as $1 per byte now, but they anticipate it may get as cheap as $0.01 per byte.
Oh!
And now you get a 16 gigabyte SD card for $8.
For chips.
And that is 16 billion. Right? Mm-hmm. So we're in a world that was just unimagined back.
Right.
If you go back far enough, 640K, who could even imagine such a thing?
Yeah.
But now we live in this world where memory is so cheap and there's so much of it and it's so fast that they can, not only is it how much there is, but how fast can you read it?
Yeah.
So when you're transferring data between devices, so you log onto the internet and you've just looked up things and you get an image. Well, how fast, what's the bandwidth? So how much comes down in each pulse that you're getting onto your device, and how many pulses do you get a second? And that's your transfer rate. And on a lot of devices you used to have to set the baud rate. And the first modem I ever used was 1200 baud, which meant it's 1200 instructions per second, and it was 8 bits.
This is just, it's giving me flashbacks to dial-up internet when you'd be loading a
Yes.
picture and it would
be the first thing I ever did, I was actually working with Ken Percival, another guy that you would vaguely know.
You don't know them. We do.
Yes, but he is a very interesting, unlike me, he's a bit nerdy. But we were writing a program, actually a transliteration program that was translating Bible from Fulani Arabic into Arabic characters, and Ken worked out all the algorithm. But it was before the internet.
Oh, what?
And he loaned me, yes, there was such a time, and he loaned me a modem, and he set up his computer as a bulletin board, and I would set my computer up to dial that modem, and it would ring his home phone number, and his computer modem would answer that call, and then he had software running on his computer that let my computer then log on to his. And one of the things you could do is transfer files. So you could just type, because you couldn't use the phone right? So I was writing the code, because he was stuck with that, but he was developing that. So we talked to each other over the phone, back when you were paying STD rates, when it wasn't sort of, it cost you to ring long distance, and Wollongong to Nowra was long distance. But you dial in, and then they'd negotiate, and you get the right, and then I could talk to just him, and then he could send me a file, and then we'd hang up and we'd go, can you believe this amazing thing? Normally I would have had to drive down to Nowra, you would have to drive up with a floppy disk, but now I can just ring you up, and it just dials across, and we were just blown away. This is new technology. But you look at it was 1200 baud, and now we're talking about 100 megabit.
My goodness.
Right. So all of this stuff we just spoiled. Yeah. We just spoiled. And we're just used to it. And it's on your phone, and it's all around, and you walk around, Wi-Fi, well, of course, I can't believe it. I don't have 4G here. Oh no, this is too slow. But if you look at old websites, they were really, everything was tiny little thumbnails, and if you wanted to actually see, you had to click on it, and then it would go down like that, and it download the file.
Very, very slowly.
And now everything is just, there it is. So, but this is what it all comes down to. Does this make some sense to you?
It does make some sense to me. I mean, for sure I won't be able to explain it back to you in a week's time, but at the moment it makes sense. And on the bright side, there's a video to
right.
re-explain it to me when I forget.
So So this is the language that we have to make your game.
Translate into.
Yeah, we have what we're beginning is the process of translating your ideas that you just described that is bundled down on the floor into this. This is really the background of what you need to be even able to begin to write your game.
Right.
And so it's probably a reasonable place to
call it.
To call it for now.
Yeah.
But
introduction and coding languages.
Yeah. So, but the important thing is you've got an idea.
Yeah.
And you want to make it happen on a computer. This is the way the computers work.
Mm-hmm.
We have to translate your idea, and what we're probably going to do, and I would suggest would be the way I would do it. Now, there people might be on YouTube that are your big fans that really know about these things.
Leave your suggestions in the comments below.
Leave it here. That they might be going, no, this is the wrong way to do it. There's a whole new intuitive language. It's so much easier. I don't know it. I don't get it. I don't have it. I know what I know.
Right.
And I do know how to write what I know how to write. So the way that I understand this as a non-gamer, as someone that normally programs devices to collect spectra or whatever, this is the way that I know how to do this. Mm-hmm. And I believe we can do that. So what we need to do in the next one, because it was never going to be written in one, right,
never would have worked,
is now armed with this information, and maybe you need to watch back parts of the, you could be one of my viewers and get my video views up from 1 or 2 that I normally get.
Yeah.
I do have one with pushing 16,000.
See, that's good.
On flooding secondaries on Holly-Carburettor. That's been the real goer for me.
Yeah, well, that's the talk of the town. Is
but
flooding
for my 1936 Buick. But anyway, go and visit my other videos and get the views up from, if you want to know how I fix my shredder, my mulcher.
Yeah.
It's all there for the world to see. But so for this one though, if you go back and you can go back and revisit this and remind yourself, and it means you can prompt yourself with more questions.
Yeah. So
I will put this up fairly soon, and I will consult with you about what clickbaity title it should be given, and all the information metadata that we should put in to get that, and then you can tweet all your fans and have your tweet ignored.
Yeah. Oh, jeez.
Or not, but anyway. But it means that you can go back, and assuming that we can read this, and I think we probably can. I mean, I hope that...
I have high hopes.
I hope that we didn't go above the top. I don't know, there you go, look at that.
Yeah, look, I feel like we checked pretty well at the beginning.
Yeah, no, that's...
Yeah, we're good.
All right.
We're good.
I don't think I went any higher than that. So, you can go back, but then what you have to do, assuming that we've made a decision to do this in an object-oriented way. Mm-hmm.
I think so, personally.
And that's the way I work. Mm-hmm. And I'm not a gamer. I don't play games. I never had...
We can at least see how
console.
it goes.
No, that's right.